Hey guys, welcome back to Jyoti classes. And last I left the video on the numerical techniques, and we need to solve the questions based on that. That is Newton-Raphson method, trapezoidal method, Simpson 1 by 3rd rule, and 3 by 8th rule. I will be uploading the solution with the problems in the upcoming video. So today we will be continuing the remaining part of the MMP, that is mathematical physics. So today in the class we will be going to learn on the second order differential equations. We know that there are two types of differential equations. One is homogeneous differential equation and the another one is non-homogeneous differential equation. Okay, so how to differentiate whether it is an homogeneous differential equation or non-homogeneous differential equation? Just what you have to do is, if the RHS part is equal to 0, then it is an homogeneous differential equation. If the RHS part has any value, it may be anything, then that equation is called as non-homogeneous differential equation. Okay, so let us start with the homogeneous differential equation. The equation form is d square y by dx square plus p dy by dx plus qy is equal to 0, where p and q are the constant coefficients. How to solve this? First of all, to solve this type of equation, we need to find the auxiliary equation for the given differential equations. Okay, how to find the auxiliary equations? What you have to do is, let us take y is equal to c into e to the power of mx, which is the trial solution, where m square plus pm plus q is equal to 0. Here m square is nothing for y double dash and m is equal to for y. Okay, this is what we are taking. Okay, and now equate it to 0. You know how to solve the any quadratic equations. To simplify that, find the roots for that given equation. You will get two solutions as m1 and m2, and these two are our auxiliary equations. Okay, and after that, based upon the type of auxiliary equation we received, we will be going to have different type of solutions. For example, the first case is, if m1 and m2 are real and unequal. Real and unequal, I mean 2 or 5, something like this. If we have the solution like these are real also and unequal, then the solution for this given type of m1 and m2 value is y is equal to c1 e to the power of m1x plus c2 e to the power of m2x. Okay, next, for if the roots are real and equal, if the roots are real and equal, then what is the value? The value is y is equal to c1 of x, c1 plus c2, c1 plus c2 of x e to the power of mx. Okay, next, if the roots are complex numbers, if the roots are complex numbers, then the solution y is equal to c1 e to the power of m1x plus c2 e to the power of m2x. This is similar to the real and unequal. Okay, next, if the roots are complex conjugate of each other. Here complex conjugate, I mean the solution may you may have the root as m1 and m2 is equal to 3 plus 2i by 2, something like this, or 3 minus 2i by 2. These are complex conjugate numbers. Okay, if you have the root something like this, then the value will be e to the power of alpha x a cos beta x plus b sin beta x, if m1 and m2 are alpha plus or minus I of beta. As I gave the example before, this is similar to that form. Okay, next, coming back to next formula, that is Wronskians of differential equations. if y1 of x and y2 of x are two solutions of an second order linear homogeneous differential equations, then the formula will be w of y1 y2 of x is equal to, this is the form, that is y1 of x, determinant of y1 of x, y2 of x, y1 dash of x, that is first differential form of the y1x and the second differential form of the y2x. Okay, depending upon, if when you find the solution for this part, and based on that what you have to do is, if this w of y1 y2 of x is equal to 0, then we conclude that they are linearly dependent values. If the value is not equal to 0, then we say that they are linearly independent values. Okay, when you solve the questions you will get more. So now just focus on the formula, and the next by the upcoming days we will be seeing the problems and you will get them clearly. Okay, next, here the linear differential equation. For that, this is the form I written. You have to just find if p and q are the constant. See here, what is the difference between that homogeneous differential equation and linear differential equation? Here dy by dx plus p of y is equal to q. RHS is having some value, say it has q. Then how to solve these linear differential equations? What we have to do is find the integrative factor, that is if, for the given equation, that is e to the power of integration of p dx. Just put the value of p here, integrate, you will get the value in terms of exponential. Then after finding the if value, find the complementary function cf value, that is y plus if is equal to integration of q into if dx plus c. Here you will get the solution for y value. This is the way for linear differential equation. Non-homogeneous now completed linearly, and the next form is exact differential equation. If it is, the equation is a form of m dx plus n dy is equal to 0, then what you have to do is, if we partially differentiate m with respect to y and n with respect to x, if they both are equal, then this form of equation is exact differential equation. Then how to find the solution for that? What we have to do is integrate m d with dx with the y as a constant, and integrate n with dy with x as a constant, that is equal to c. Okay, next, now coming back to non-homogeneous second order differential equation. For non-homogeneous differential equation, the equation form is dy double dash plus py dash plus q into y is equal to rx. Okay, here take d by dx is equal to d, the function reduced to d square plus pdf plus q. Find the complementary function, find the particular integral. How to find the complementary function? Similarly, the way we find our roots, and find the particular integral depending upon rx. Okay, what type of rx we are having, depending upon that you have to take the particular integral. So what are the possibilities for rx, and what will the value of pi for that? First part, if rx is an exponential to the power of ex, then our particular integral will be 1 by f of d e to the power of ax. In f of d, what is the value? Put the value of a, then equate it to 0, you will get the value. Further simplify it. Okay, in case if f dash of a is equal to 0, then take f double dash of that and find the remaining thing. Okay, next, if rx is a polynomial, then the particular integral will be 1 by f of d x to the power of n. If rx is sine of ax or cos of ax. Find the particular integral 1 by f of d square sin ax or 1 by f of d cos ax. Sin 1 by f of a sin ax, f of 1 minus a square. Here, why this I will tell you in the solution part. Okay. Now next, if Rx is this form e to the power of ax into phi of x, then particular integral will be 1 by f of d e to the power of ax phi of x. Then e to the power of ax is f of d plus a phi of x. Okay, just simplify it, you will get the further answer. Next, coming back to the green function, madam. Okay, this much for the today's class, and thank you guys.